Okay, I just want to show you about the plant pot that I am designing. I'm gonna close it. Okay. So I have a metal bar which I have deleted. So the bar will run across sorry, in this direction. And I want to hang the plant pot on that metal bar or on that metal bar using this hook. Oh, actually my scene doesn't have any caption anymore. Oof. Yeah, because I accidentally deleted OBS when I was cleaning the computer, and my caption is now gone. So that sucks. But okay. So what is the surprising thing? So let me just break it down part by part. All right. So this is the part that I am making. This is the top down view. And when we take the measurement of the wall thickness, you see that is 2 millimeter all around, because I want to print the entire part in vase mode with the extrusion width set to 2 millimeters. Because I have recently bought a 0.8 millimeter nozzle, I want to try and utilize vase mode as well as push the volumetric flow of the hot end to the limit. Okay, so the part basically have two hook, two holes for the hook to connect with it. You can see down here. I can turn off the transparency mode by using V and T. Select VT. Not working. Have to turn off the measurement. Let's get again VT. What? Active body. Yeah. Click on it. VT. Okay. What's going on here? Some reason. Oh, I have been setting it to Vietnamese. Sorry. Yeah, it works now. VT. Yeah, language actually affect how the shortcut works. It actually affect how the input works in Sifu, the fighting games. Okay, so we got the hook, we got the base. So the base have a 2 millimeter bottom. I hope that is enough. Because this thing is going to be filled with dirt, and yeah, I am having some doubt that it may not hold, but we'll see. We have to see. Okay, we got that. We got the hook. Now for the design of the hook, let's check. Okay, so yellow part is the reference to the part over here. So we just let me turn it back on. Where's the part? Okay, the part is up here. So we are designing the hook from this side, and you can see the hook is like hooking inside the hole over here. And I have gave it some clearance as well. Now, because I want to print the entire thing in vase mode, so the end to end. So because my extrusion line, let me give you an example. So like GM. Oh, okay. So like the distance from here to here is actually 2 millimeter extrusion, same as this one. Okay, and by designing it that way, I can make the filament start from one end go all the way down here, go up the hook, and then go back down again. I have given it a 0.4 millimeter chamfer. Oh, I'm sorry, fillet in the design as well, so that I can fine tune the control. The curve up here is much more forgiving, so it goes up, over, and mid, go down and mid it right here. So at first I thought I need to design a slit in the middle like this, but it is actually not needed because the slicer take care of that for me. So let's go back to the slicer, and I want to show you something about what is so nice about the 0.8 millimeter nozzle. So this is my 0.4 nozzle profile. This is the speed. Most of the setting is the default, if I remember correctly. So, and it zip around pretty fast. You know, you can go through quality 0.4 default, yeah, 0.42, 0.5. So this is the mostly default value. And because this is a 2 millimeter walls, it had to like make multiple passes in order to create a 2 millimeter walls. So let's try to slice that one, and we got this thing, 256 grams of plastic, which will equate to 38,000 Vietnam dong, and 8 hours of print. So a lot of power consumed, and because they have to go layer by layer and have to zip around like that a lot. Usually zipping around is not that big of a problem because the printer nowadays are actually very fast and can handle the speed. The problem, I'm sorry my friends, the problem is that when we get high enough, so like up here, it can introduce some ringing. So like the acceleration, I don't know, the sudden acceleration at the corner will cause some ringing, and also because this is a bed slinger, so it will slide back and forth like that, and the walls up here can actually flex a little bit because of a sudden acceleration. Now we'll go to the 0.8 millimeter nozzle. And what I have set up here is 0.5 millimeter layer height as opposed to 0.2 millimeter. So like over double, yeah, more than double. 150%, no, that's like 250% like in increase in layer height. First layer height is still 0.2 for ease of removal. Line width, yeah, line width is 2 millimeters for all the layers. I use this value because this is actually the outer diameter of the 0.2 millimeter nozzle. The first layer stay 0.8 millimeter because I need maximum resolution for it to fill all the nooks and crannies in the first layer. So I will show that later. For loops 1, because this is actually spiral base mode. All right, so we slice and we go back to the couple first layer. You can see because the first layer use a 0.8 millimeter nozzle width, you can see it fill in very nicely for the first layer, ensuring a nice finish at the bottom, and yeah, a stable base for later. I have also added some mouse ear, yeah, so it can hold better. That is for the first layer, but for the second layer you can see the thickness is significantly more. So this is 2 millimeter layer width, and just walls after walls. It just took like, wait, 1 2 3 4 5. 1 2 3 4. So like 1 2 3. So like 3 walls. I think it's a little bit thin, isn't it? Oh my god, let me double check. Click the object, view distance from 2 mm, 5. So like what? It doesn't really add up. I think it is due to the resolution. So like 1 layer, 2 layer, 3 layer, and that is a wall. That is a wall. So like 3. Okay, so in reality I have like 1 millimeter of walls instead of 2. Okay, that might be a bit of a problem. I should have turned on, can I do that? Like precise the quality, right? Overhang, wall surfaces, ironing, precise. Okay, I did turn on precise the height, but for some reason something doesn't add up. What is the first layer is 0.2, so I only have like 1.17 millimeter instead of 2 millimeter. Okay, note taken. And I think the time is significantly less, from like 7 hours, almost 8 hours, down to 3 hours. The filament consumption is still about the same, so like 30, a bit less to be honest, because of the missing layer, I assume correctly. And yes, yeah, so like less power use, less time consumed, so, and also less mechanical vibration, because for any given layer it only need to make a single pass to complete the layer. No need to zip around 5 times to create a layer. So that is a major advantages. And yeah, because people said that the printer has maxed out the parameter at a 0.4 millimeter nozzle. It may be true when you try to squish it out. So like go back to 0.4. Maybe we can significantly increase the layer height, so like almost 0.3 millimeter, while also increasing the extrusion width. Then yes, maybe we can reach that limit, perhaps. So like, but it is still far from the structural result that I can get from the 0.8 millimeter nozzle, especially when using vase mold. So like most of the time we use 0.2 millimeter nozzle. Like it is very, 0.2 is actually very nice for most of the stuff, and I would consider that to be too nice for some application. So yeah, but 0.8 and how much like 0.4 maybe, so like 150% of 0.4, so like 0.6, right? No, 100% increase. Yeah, 150% of the nozzle diameter, so like just 0.6 millimeter extrusion width, which is nothing. I feel like a 1 millimeter wall is too flimsy, even if it is in layered printing mode. This thing, if I print it in 0.8 millimeter nozzle, it is completely solid because there is no seam whatsoever. Yeah, and then there is another advantages. I kept forgetting that the printer is printing, because it doesn't have to do this. It doesn't have to like roam around with like max Verstappen, like back and forth with maximum acceleration. The belt noise is significantly less, both on the Y and X axis. It doesn't have to dart around, making multiple loops. Yeah, it is just so quiet because the extruder gear doesn't really do anything that noisy. I don't think it actually make a noise because the gear is like plastic to plastic contacts, and it is actually very slow. So yeah, got that one down. And so that is how I printed. Oh, I forgot to show you the other thing, which is the hook. 1 second. Okay, 0.8mm nozzle, base mode, lay down, strength. So it's lagging. Strength, yes. Okay, so I slice it. I think I should keep this model. Yeah, you see, because I use 0.8mm first layer, it actually does a lot of this zigzagging back and forth, and I believe that is the reason why my model have the hook that I'm currently holding have a terrible corner around this area, probably because of that, maybe. So if I change that to 2mm, none of that problem. So go back, just zip around, print the brim. The nozzle is just too big for the brim to stay consistent. Yeah, I'm just going round and round and round like that, costing me how much money? 4,000 đồng. Yeah, I think it's 4,000. So very cheaply made part with exceptional accuracy. And because vase mode generate this part, because the distance between this surface, I should just go into that, to here, this wall and this wall is 4mm, and the extrusion line is 2mm. The generated walls that I am actually holding actually literally fuse with each other. Like I cannot split that apart, and it is yet completely fused all the way, except for the top part. For some reason, I don't know if it is just due to some thermal shrinkage, but there's a bit of a gap on this section of the hook. So I love vase mode. Yeah, and with the chunky layer lines, oof, the print became a breeze. I can actually make like functional part extremely quickly now. No more retraction needed. Everything just run very quickly, and I enjoy the process of designing around the real world limitation of my hardware, which is the bed requiring the first layer 0.2 and the nozzle as well. But yeah, those are the trade-offs that I think worth it for a lot of the application. Of course, when fixing stuff in the real world, you may not have the luxury of choosing these parameters yourself. But I mean, like, you can get pretty far with appropriate design. And remember, if you need the details like different colored filament, you can actually get this down to 0.8mm. So I don't believe it's that bad. at all. So, as usual, the journey of 1,000 miles begin with a single step. Update on the vase mode design is this thing over here. So I have made a sort of hanging plant pot for my home, and I printed these S hook separately and welded them onto the vase mold base. So this is 2mm walls. All of these are printed in vase mode, including, zoom in please, including the hook themselves. Similar for this one, but looking not very fresh right now. So same thing, had a bit of an issue with the temperature and flow and stuff like that. Same logic, printed separately and plastic weld on them using a soldering iron, and I have a lot of hopes on this one. So basically this will be an experiment on how well PETG can hold themselves in front of UV. So my house is facing east this way, so it have a pretty large amount of sunlight every day. And yeah, you can see the weld, the black weld between the bars over here. Yeah, so those are all black PETG filament, and they are fused together to make it stable as possible. So all the project is in vase mode, and yeah,